Hey natural farming family, Chris Trump here. I am at Grand Teton National Park. It's beautiful. There's all kinds of good mycelium under the trees. I thought today would be a good day to talk about IMO, indigenous microorganism, what it is, how we cultivate it, what can go wrong. Hopefully I'll show some examples in coming videos, but today I'm just going to talk about it. A lot of people have a ton of questions and want to know what's what. So yeah, can you see the beautiful mountain in the background? I don't know if you can. This is nature. When we cultivate crops, what we're trying to do is make our veggie plant or whatever it is we're growing as disease resistant and as healthy as the wildflowers, where nobody's out there spraying them and year after year they're healthy, they don't die off, they just thrive. Why? Well, because this place is ideal for them to grow. That's why they grow here. We're entering a new era in our generation of microbial understanding. When I was at school, we did a auger petri dish sampling of what we could find on our keyboard, and you know, that's really helpful, and we've gotten a long ways learning about microbiology that way. But in this generation, we're gonna learn about the symphony of nature. We're gonna go into it as a frontier, how everything works together. It's so complex and so beautifully connected and interwoven as far as how everything works together. And we're just starting to understand exactly what that is. It's awesome. It's awesome to be in a time where we can dig a little deeper. This summer, actually, just in a few weeks, I'm going to be working with a doctor from MIT and one of our beloved extension agents from Hilo, and we're going to dig into IMO, indigenous microorganism, several stages of it, and we're going to take triplicate samples and we're going to use MIT's labs to study what this microbiology, what these microbes do from stage to stage, using what's called shotgun metagenomics, and really kind of the only tool we have to properly study the massive diversity in nature in the microbial world. And so it's really exciting for me. It's just fun to dig into this stuff. So I'll share those results with you and what we find, but right now I just want to talk. I'm just going to run at the mouth with IMO information. So we have IMO 1, which is going out into the forest, cultivating some of this leaf mold we find onto rice and getting it to bloom. That whole process, IMO 1. When we take that process and mix it with sugar, that is called IMO 2. Now it's in a dormant state. I'll get into that in a second. That on that shelf, that material is IMO 2. Then when we take that IMO 2 and kind of grow it out on a substrate or some kind of material we have on hand, we call that IMO 3. Then when we take indigenous soil or dirt and mix it with our IMO 3 and grow that out, that introduction of soil with IMO 3 is called IMO 4. And then when we take that IMO 4, if we need to, if we want to, and mix it with some kind of high nitrogen material or inoculate it with our material with IMO 4, we call that IMO 5. There's a bunch of variations of IMO 5, but yeah, that using IMO 4 to get something high nitrogen going or inoculated or finished properly. So those are the stages I want to talk about today, and just a little bit about kind of the natural farming theory in IMO. So in IMO cultivation, in natural farming, the theory is this is the foundation, this is the basic place to start to build good farmland and healthy crops. We want to start with natural farming's indigenous microorganism number 4. And so all these processes to get that good start with indigenous microorganisms. So just in case you missed it, I, indigenous, M, micro, O, organisms. It's one word, but that's where we get IMO, the acronym. So why start there? Well, because everything that's happening from the way we see it, and kind of using this natural farming method, is the plant's health underground is all representative, or will dictate its health above ground, its productivity and everything. And the health below ground is best served with a healthy soil food web. That soil food web is the concept of this symphony, this interconnected relationship between microorganisms and macroorganisms, or slightly larger organisms like earthworms and moles even, and microarthropods and nematodes, all these various bits and pieces that are going on in the soil, that all working together with the plant's roots photosynthesizing. That's all kind of this concept of the soil food web, and it works together in amazing ways, really, really beautiful ways. And so IMO, I'll just go through them real quick, some of the questions of what can go wrong, why it's wrong. IMO 1, people go to like their trash pile or their compost pile, and they stick some rice. I'm talking about some of the things people do wrong. They stick some rice in that compost pile or in their worm bin. That's cool, and they get something to bloom on the rice, and they say, look, there's something living on the rice. What's wrong with that? Well, the theory is that we're going for maximum diversity, and we're going specifically, or by and large, we're going for fungal diversity. And bacteria and yeast, don't get me wrong, but a lot of that comes almost automatically when we tend to the fungal diversity. So a lot of these concepts that you're going to hear in the theory have to do with tending to fungal growth. For example, one of the natural farming theories is 7 shade, 3 light, or 70% shade. If you look in this forest, under the canopy of these trees, you have this spattering of light and dark, and that moment, that environment, those scenarios where there's shade and there's sunlight, all kinds of cool stuff happen in the forest. And so we're trying to emulate that, again, just observing nature, to give ideal environments for microbes. Back to IMO 1 and diversity. If you cultivate out of your worm bin, what microbes do you have on now your rice culture? How diverse are they? Well, they're only as diverse as what you put into the worm bin, what ended up in your worm bin. Okay, so we have a limited diversity based on whatever's growing there. Well, I threw a bunch of things in. Okay, well, peels from your banana from the store, those probably got bleached. There is some microbes, maybe it came from, John Doe who was handling the banana before it went on the shelf, Anyways, limited culture. Your compost heap, well, maybe it came from 2 trees and 1 bush in your yard, or maybe it came from, 3 or 4 things. Whatever those have on it is what's kind of in your compost heap. Then we go out to nature, and we go to an environment like this, a wilderness that's never been in cultivation. What microbial diversity might we have here? Could it be more than, say, our worm bin that had, last week's lasagna and all the fruit we've been eating and etc.? Not too much lasagna, your worms won't like that. In the wild, we're going to have different diversity. For example, there's a place in Hawaii where I live, we're in Idaho now, and up on the hill there's a place where nothing was ever cultivated. It's just grassland, and it's somewhat untouched. There's ohia trees. Right there, a scientist studied this line between just down the hill where it had been cultivated in sugarcane and just up the hill where it had never been touched, and the microbial diversity was 10 times uphill what it was downhill where there had been cultivation versus where there had not been cultivation. Meaning he found 10 times the amount of different types of microbes just a little up the hill, not a few hundred feet away. Why? Well, because some of these microbes don't fly in on the wind. Some of them take time to get established. They come and arrived maybe on a animal's feet, or in a bird's poop, or all kinds of different ways. And those take time to get established, and when destroyed, they don't just pop back on their own. Maybe they're delicate, maybe they require time to really multiply and expand. We want that kind of diversity in our IMO collection. We need it. And so that diversity is what we want to collect on a box to make our IMO 1 and 2 in a box of rice. So is that different than my compost bin or my worm bin or my rice that I left in the rice cooker and something bloomed on it? Yes, it is very different. You can't see it, maybe. Maybe you say, well, there's white fluffy stuff in my rice cooker where I just left my rice. The stuff I ate 3-4 days ago, I left my rice cooker there and it bloomed. Isn't that IMO? No. Okay, so here's the theory. We want maximum diversity because a lot of our disease-causing microbes, or things that cause plants to suffer, thrive they're opportunistic. They thrive in an environment where there's blank space or opportunity for them to get established because there's not a ton of diversity of microbes. What's the difference between the soil I might pick up here in the Grand Teton National Park and some potting mix I grab at Home Depot? Well, they both look dark. What's the difference? Why is one going to be better for microbial diversity than the other? Maybe you can't see that with your naked eye, but I present to you, this is very important. They are very different. And in the same way, indigenous collection, or a collection in a wild environment that's been somewhat untouched for as long as possible, I look for areas that I know, or I find out the longest possible lack of human contamination or man's digging in the soil and dumping things in. That's where I want to collect IMO 1, because I know that has the potential to have the maximum diversity. Well, Chris, you don't know exactly what's in there. You're right, I don't. In this world of microbiology, we don't really have the answer of what every single thing is yet. But we do know that there's more diversity in these kind of wild, untouched areas than there is in these cultivated or land that got turned into a parking lot and then torn up. You get my point. So, IMO 1, the theory, maximum diversity. We're looking for an area as nice and healthy as we can find that isn't being cultivated. So go look for a beautiful spot where all the plants are thriving and nobody's done anything there, and say, that's thriving for a reason. I want that perpetual health in my environment. Another thing is indigenous. By collecting in an area where, in the general vicinity of where you live, you're seeking out indigenous biology. That's going to thrive in your rainfall, in your barometric pressure, in your temperature. That's the stuff that's going to love the area where you live in. And so we want to go there and find things in our environment. Well, Chris, I live in a city, there's nothing near me. It might be worth taking a trip into the country. Well, that's an hour away. Take a camping trip. I don't know. Find a friend that lives in the country that can do this for you. There isn't a real way to cheat this. This theory, this concept is really a large part of the strength of natural farming. And it's strong for a reason. This is really cool. And so maybe you live in a city. I talked to somebody who lived in Bangladesh, and they're surrounded, and I feel for you. That's hard. Maybe you can do something. Maybe you can't. Maybe you're in Bangladesh and you're just not going to get out beyond the borders to a place really wild, long time, outside of kind of cultivation. Do the best you can. Look for an area, maybe a park, and it's been a park for 30 years, maybe, I don't know. But the best you can do with this concept, with this theory in mind, is what I recommend to you. Again, that might not be as good, but ultimately you only can do what you can do. In Hawaii we say, if can, can. If no can, no can. This is kind of my answer to that. All I can do is give you the information. I can't do this for you. So here I am to say, there's a reason we want maximum diversity and indigenous. And it's solid science, it's good theory. So, IMO 2, super straightforward. I got my IMO 1 collection, I'm super stoked. I'm gonna go make IMO 2. How long do I have between 1 and 2? Can I set it on the counter for a week and take some pictures and send them away and see if people think I should make IMO 2, and then a week later come and massage it with brown sugar and it's all the same? No. IMO 1, you want, for me, it's like within the hour of opening that lid, disturbing that IMO 1 collection to making IMO 2. I don't want to waste time, because I don't want anything that was kind of migrating in to kind of fade out. I want that kind of moment of vitality where everything's blooming in there. I want to take that and put it on ice, so to speak, right away. So IMO 2, the concept is to use sugar to cause things to go to sleep or go dormant in the state as close to nature's collection as possible. Is this perfect? No, it's not. Might there be a slightly better way? Maybe. Is molasses a better way? This is a question I get a lot. No, molasses isn't. Yes, does molasses have a lack of oxygen, so it keeps things from going off inside? Yes, it does. But molasses doesn't do what brown sugar does. In this particular instance, we really want a sugar. Could I use some other sugars? Sure. But a sugar has a dryness. This is what we're going for. That dryness, when mixed with these living bodies, these microbes, pulls on the moisture in the microbial environment, trapping the water in a chemical bond with the sugar molecules. Why do I want this, Chris? So most, or a lot, not most, a lot of these microbes have a spore state where they'll sporulate when they get in a non-ideal environment. So you've given them an ideal environment with this nice, somewhat moist cooked rice and a lid on it that allows them to regulate their temperature and their moisture, and they bloomed. Now I put them with so much sugar that much of the water is trapped and they go dormant. But I don't want to put them with way too much sugar, because then all of the water is trapped. It's almost like putting them in just the right state. I like the example, the sci-fi example of cryo-freeze, where, you know, they're sending the astronauts on a journey to a distant, you know, nebula or distant galaxy, and they put them into this pod and they put them into cryo-freeze, and the person just lays there and their body's still alive, but they kind of go to sleep for like 30 years or something, and they wake up at the same age. This is kind of what we're trying to do. We're trying to take this diversity, we've gone for maximum diversity, we're trying to take this diversity, as soon as possible, get it with sugar, so that it all goes to sleep just like that. Nothing changes. And just enough sugar that there's almost this like slow life that happens. It doesn't like go off and become alcoholic. It just kind of lingers, and we have a good collection that's now shelf stable of our area's indigenous biology. So that's what we're doing with IMO 2. The concept is to change as little as possible from our initial collection to what goes on our shelf in preparation for IMO 3. IMO 2 is really awesome even if you don't do the rest of natural farming. IMO 2 is now an indigenous inoculum from your environment, and you could use that to treat all kinds of stuff. Put that in some water, and you could do, I mean, as soon as you add moisture back into that environment, you take some of that IMO 2 and reintroduce it to moisture, those things wake up. Now you've given them access again to the moisture, and they're in a different environment. Moisture and oxygen, they're gonna wake up and they're gonna do their thing. So maybe you're a farmer and you need your own inoculum. You're buying bugs in a jug, some kind of EM or bacterial, you know, container full of stuff. Now you can make your own, and it's really, really simple. You don't need almost anything else other than rice and a box to put it in the forest. So there's IMO 2. IMO 3 is a grow out of IMO 2 onto some sort of substrate. Real quick, I'll repeat this. IMO 3 and IMO 4, you turn them every day. We don't leave those things to sit and not turn them. You got to turn them every day. This is vitally important. You will see, if you skip a day turning it, you will see a drastic change in smell and overall performance of these microbes. We are focusing on cultivating the aerobic microbes. Well, aren't anaerobes important? Don't we need anaerobes too? Yes. But anaerobes are so easy. They're going on, and once you get the aerobic guys going, anaerobes go nuts all on their own. So yes, anaerobes are important, but really in natural farming theory, we're trying to take care of bringing that indigenous biology, anaerobes and aerobic biology, and getting them onto our cropland. Well, don't I exclude anaerobes if I do this turning every day? No, they'll still thrive in that environment. They just won't be the only thing you're cultivating. If you get a pile and you let it go to 140 and you never turn it, generally speaking, anaerobes will be the only thing you cultivate in that pile. The aerobic stuff won't multiply. Yeah, so bear with me. I'm just kind of running into a bunch of different topics. I love to talk about this stuff, but I recognize several of you don't have opportunity to talk about these kind of things with somebody that knows what they're talking about. So I'm just going for it. IMO 3. Ideally, we want to stay at 120 degrees max or lower to cultivate our IMO 3. What happens if it gets to 130? 130, sometimes it's okay. You're into danger zone at 130. You know, sometimes an area will be at 130 and the rest of it won't, and you're still fine. If you're getting into 135, you've probably gone into actinomyces type biology, actinobacteria, anaerobes, and they're going to multiply so fast and keep that temperature really high. You're going to smell kind of an ammonia, and it's going to be pretty hard to recover if you get that hot. Well, what if I am getting hotter than 120? What can I do? There's a few things you can do. You can spread your pile thinner. So maybe your pile's stacked at 18 inches. 18 inches is the recommended height for IMO. If your pile's getting kind of hot, or you're worried at that height, you could spread it at 8 inches. And what this does is it allows more oxygen into the center of your pile, and you'll have less chance of the anaerobic bacteria running away with the temperature, because they multiply so fast that they can really get that temperature up there. So you can spread it thinner. You could bring in wood chips or some other dryish material and turn it into the pile. Well, why did my temperature go high? There's a few reasons your temperature could have gone high. You could have added too much moisture in the beginning. I would say that's the probably number one most common reason your temperature went too high, is that you got it too wet to start, and so that center of your pile, because of so much moisture, that water didn't allow the oxygen to transfer into the center of your pile. Another reason your temperature could have gotten too high, I've found, is only rice bran or only wheat bran, some of these things that are really packed in carbohydrates, without cutting them with another material. That can be so much carbohydrate, so much sugar, that almost every time that's going to run away temperature wise. And I've found a really useful thing is to take that rice bran, take that wheat bran, and cut it with some woody material, some high carbon to low nitrogen ratio material. Sawdust, if you could get some natural sawdust, that would be great. Wood chips, you could use straw. Ideally you want untreated material, but something that's not a ton of sugar but mostly carbon. So I recommend a carb and a carbon. Play with the ratio on those. It kind of depends on what you're using for your carbohydrate. Can I use grass for my carbohydrate? No, grass just doesn't really have any place in IMO 3. Sorry, it's not the concept. Well, can I insert anything you're asking about? I can't answer all of those. I can tell you generally you want this complex sugar and carbohydrate. So like a rice bran or a wheat bran is going to have a bunch of rice left over, little bits of rice or powdered wheat, and then it has that rice hull or wheat hull, and that's a really great balanced material for growing this stuff out on. You can use other stuff though. There's a ton of stuff. I played with a bunch of stuff. One of the things, I grow macadamia nuts in Hawaii, and one of our waste products is macadamia nut fines, where they've been roasted, and there's just some powder that comes out that's macadamia nut. And then I have macadamia nut shell powder kind of that goes with that, and I combine those, and I have a kind of a carbohydrate. It's kind of high in oils for this, but it works. I find I have to add a little bit more of that carbon material because I don't have the same kind of oxygen transfer. Alright, so IMO 3, you can watch my how-to IMO 3, but some of the things you can do wrong is start out with too much water, or you can have a material like rice bran or wheat mill that mill run is just a little bit too much solid carbohydrate, and it'll just get so hot. There's a lot to that. I'm not going to go into everything. I'm trying to keep this somewhat succinct as I talk about this, but yeah, IMO 3, you're going to have to play with that. One of the things I did when we started out, we were kind of a young community in natural farming in Hawaii, is everybody was having trouble with this temperature spike in a wet tropical environment that we have in Hawaii, this recipe of rice bran and for IMO 3 exactly as it came from Korea was a little off for us in Hawaii. Everybody was overheating their piles, or a lot of them, unless their pile was super small. If they tried to do anything bigger, it was all overheating. And so I did side by side, again trying to understand this side by side with rice bran, mill run plus wood chips, and then mill run plus wood chips and humic acid. Why humic acid? Well, as I talked with Master Cho over the years and just kind of heard him explain this theory, that leaf mold, that leaf litter, he collects that for the humic properties of that. So sometimes adding leaf litter into the IMO 3 process is something he would do, which is that sticks, decomposing sticks and leaves that you might find in a forest. He would throw that into some of your IMO 3. So he'd have IMO 2, his mill run, or rice bran, and then some of this leaf litter. Well, what is that leaf litter? Well, it's humic and fulvic acids. It's fungal foods. And so off that theory, I did these side-by-side trials, and the mill run, I looked at it under a microscope, and it was good growth, diversity, fungal and bacterial. The mill run plus wood chips, astronomically more fungal growth. The mill run plus wood chips and humic acid, even more fungal growth. And so I just went with that. That is now my practice, because in raising trees, I really need that fungus. This also gives you a little opportunity to cultivate a little more bacterial or a little more fungal without kind of messing with your temperature. So take that as you like. I shared that with our natural farming community, and people found a great deal more success in regulating their pile's temperature by adding in some high carbon material or some wood chips. So now you've made your IMO 3. What is IMO 4? Why the soil? So in natural farming theory, we want soil from all over. If you can get some red soil, we want some of the red soil as part of it. But what am I doing? Why soil? Well, I'll talk about it in a social kind of idea. I'm taking this IMO 2, this community of microbes, and I'm introducing it to what my farmland kind of soil is going to be. And I'm giving them an ideal environment, kind of like a social mixer. I'm bringing in the drinks, I'm bringing in the food, I got the mood lighting, and I'm saying, hey guys, make friends. And now my IMO 3 and my soil, all those kind of mixing properties in my soil, I got my microarthropods and my nematodes, some of these larger organisms, and I got this fungus and bacteria and yeast going on in my IMO 3. I introduce them and they cultivate together, and I'm growing out all kinds of things, flagellates, and it's pretty cool. So now I've introduced them. Well, why? What does that matter? Well, when I put this IMO 4 onto my farmland, maybe I put it around a crop. There's not a shock factor. I'm not shocking the environment. There's not this weird drawdown kind of funky thing that happens. They just move right in. Everybody's friends already. So that's a social description, which is kind of helpful, I think. But I'm taking, I've grown out now bacteria and yeast and fungi, and I'm putting them with microarthropods and nematodes. Now there's 4 different types of nematodes. There's bacterial feeders, root feeders, fungal feeders, and predatory nematodes. Well, we hear sometimes of nematodes and we think bad. Well, only one of those 4 are bad. Now, if I'm growing IMO 4 and I'm raising nematodes in there, and they're thriving in this moist environment, am I cultivating any root feeders? No, not really, because there's no roots. So if I am cultivating any nematodes, I'm cultivating the other 3, what we would call beneficials. And so if their population is increased a bit generally I'm not going to have this issue with root feeders, because if my predatory ones are thriving because they're eating some fungal and bacterial nematodes, then my root feeders aren't going to have a chance to really get established, because predatory's favorite food are the root feeders. So IMO 4, the concept is bringing properties together, and really cool. So highly recommend you do the whole thing, all four. IMO 4 is an amazing amendment to everything you're doing. It's also kind of the foundation of natural farming. What about some nerdy science stuff? What about how this all works? It's super cool and kind of endless. When the rain falls, we get nitrogen from the air. When the wind blows through these pine needles in this pine forest, nitrogen is blowing past these trees. Microbes can cultivate and grab that nitrogen from the rain, even from the air, and process or make it available to the trees. Can trees make it available for themselves? Kind of, but not really. Rain comes down as N2. It's a non-plant available form of nitrogen. And plants don't do much with that. They can't really. Microbes, using kind of their process and the enzymes present in their bodies and functions, take that N2 and make it become plant available N3 or ammonia, and then can further process it into nitrates and nitrites, and plants thrive off that. So what if these big old pine trees behind me are covered in beneficial microbes? Well, they probably are, because they grew up out of this soil that was full of them. They got inoculated at birth, so to speak. And so when the wind blows through them, they're probably eating off the wind itself. Well, how does this apply to my crops? Well, it's the exact same thing. Our plants can actually make better use of air and rain nitrogen with the presence of tons of microbes and diverse microbes than they can without. Well, isn't that a tiny amount of nitrogen for cropland? Well, it is if your crops are used to eating off some kind of granular fertilizer on the surface and not a whole lot of microbes present. Then yes, pounds per acre, it doesn't really equate. It's almost homeopathic. But if you got a soil food web at full speed in your soil, your plants are getting nitrogen from this process that's going on, and it's incredible. The rain falls, the microbes thrive, the earthworms are coming up to eat the microbes and going back down to live. They're aerating your soil. Now you're getting better water retention, and the microbes are increasing even in depth, because the kind of oxygenated top level of your soil is increasing, and they're going nuts. The earthworms are carrying some of those anaerobic microbes down into the soil and down deeper, and they're tilling and mining this lower soil. In our orchard in Hawaii, even on the tracks where we drive equipment, initially before we were doing natural farming, I could push down 6, maybe 8 inches. I had a pressure reading metal probe, and you know, on average, maybe some less, maybe some a little bit more. It's a 3-foot probe, and after a few years of natural farming, 3 or 4, that probe most places drops down all the way to the handles without reaching a high pressure. And we didn't do anything. We don't till in our orchards. That's the mining effect of microorganisms. And there's a lot to that, and hopefully we'll talk more about that. But you can get real productivity in cropland just by tending to the life of the soil. Indigenous microorganism, I think, is a theory and a concept that we'll be using in the future. Right now, the world's just getting into all this microbe stuff. You can buy all kinds of inoculants from the store. Some of the questions I get is, you know, well, EM, how does IMO compare to EM? Well, that's a great question. What is EM? EM is a few microbes that somebody in Okinawa, Japan decided were great for crops, and he was right. And they're from Okinawa, and he puts them in a jug and he ships them, and grows them out in the lab. Now those will help grow crops, but often those will have about a 6-month fall off because they won't perpetuate in your environment because it's not as good. Guys, there's a ton of questions. One of my Patreon patrons, people that help me out make these videos, asked, when could IMO 4 go wrong? If it overheats to 140 degrees, you're probably lost most of it. If it gets super ammonia smelling, you're probably losing it. Yeah, but I'll make a bunch more of these all about videos. We'll get into OHN and FPJ. Check out some of my other videos, and let's keep talking about this. I love doing it. I hope that we have a world soon where you can buy this medicine food off the shelf, and we're finding that this food using microbes really is our medicine, the best one we can get. So thanks guys, I'll talk to you soon, and go ahead and ask questions. I'll incorporate it in some of the other videos. Peace. Hey guys, if you like this video today, go ahead and hit subscribe so you don't miss any of the future videos. Super helpful for me, and if you want to support these videos being made, that's awesome too. You can check me out at patreon.com/Chris Trump. Check out some of my other videos, and yeah, grow in natural farming, guys. I think the world's gonna change soon, and in a really wonderful way. Talk to you soon. Laters.